B1, and B1 is more multiple choice. So which conclusion is drawn from the gold foil experiment? So this is when Rutherford fired the gold foil fired alpha particles at gold foil, and most of them went through, so most of an atom is empty space. That was his result. All right, which electron configuration represents magnesium when it's excited? So first I'm going to go look up what's magnesium when it's ground. So you go over here and you look up Mg, and it's 2H2. So 2H2 is ground, so cross that off right away. 285 doesn't even have the right number. It's got to add up to 12. It's not gaining or losing anything. 276 doesn't have the right number either. 273 is perfect, because if you move one of these out, the 8 will go down to 7 and the 2 will go up to 3. So that's a perfect excited state. Which group on the periodic table has elements that tend not to bond? If you don't bond, that's because you are already perfect. The noble gases have full octets, so there's no reason to bond. They have a full valence shell. So group 18. Which group has at least one element in each of the 3 phases of matter? Well, here's my periodic table. There's actually only 2 liquids. Mercury is a liquid and bromine is a liquid. Well, mercury over here, all of these other things are going to be solids. Over here, you know fluorine is a gas, and you know that these down here are going to be solids. So this has gases, liquids, and solids. So it has all 3 phases of matter. It's group 17. You know 1 and 2 are going to be all solids, and you know 18 are the noble gases, so they're all gases. Rubidium and cesium have similar chemical properties because they have. If something has similar chemical properties, they're in the same group. So I just got to go find them and make sure. Rubidium, cesium, yeah, they're group 1. So that means they all have 1 electron in their outer shell. If they have the same number of valence, they react the same way. As the first 5 elements in group 15 are considered in order of increasing atomic number, so that means I'm going down the group, so I'm starting with atoms and they're getting bigger as I go. So first, ionization energy. That means how much energy to get an electron away from them. So it's going to take a lot of energy to get it away from a small atom, but it's not going to take much energy to get it away from a big atom. So the ionization energy is going to decrease as you go down. Which substance in the table has the strongest intermolecular force? Whichever one has the highest boiling point. I'm going to look for the highest of these boiling points, and it's 293. So HF must have the strongest attractions because it takes the most energy to separate them by boiling. Which ion in the ground state has the same electron configuration as argon? So I'm going to look up what argon has, and it's 288. So argon 288. So aluminum with a +3. If Al was a +3, instead of being 283, it would be 2-8. Not 288, so that's not my choice. Oxygen, 2-6. So if it was -2, it would gain 2 more. It would be 2-8, not 288. K+, 2881. If I'm a plus, I would lose 1, and then it would be 288. Winner, winner, chicken dinner, there's my choice. All right, what is the number of pairs of electrons shared in N2? Here's a nitrogen. It has 5 valence, 1, 2, 3, 4, 5. Here's another nitrogen, 1, 2, 3, 4, 5. It would share 1, 2, 3 pairs of electrons. It would form 1, 2, 3 bonds. So there's the triple bond. So how many pairs of electrons shared? 3 pairs, 6 electrons total. All right, which statement explains why a carbon-oxygen bond is more polar? If a bond is more polar, it's all about the electronegativity difference. So the difference in electronegativity between C and O must be greater than the electronegativity difference between F and O. All right, a mixture consists of sand and aqueous salt solution. Which procedure can separate them? So if I want to separate sand, salt, and water, let's picture this for a minute. Here's the sand on the bottom. Here's the salt, and it's in the water. I'm going to filter out the sand first, and then I'm going to evaporate the water, and I'll be left with the salt. An aqueous solution having a mass of 490 grams containing 8.5 times 10 to the negative third grams of calcium ions. The concentration is. Now the answers are in parts per million. So I'm going to go over here. Parts per million is equal to the mass of the solute over the mass of the solution. So the mass of the solute, so the whole solution is 490 grams. There's 8.5 times 10 to the negative 3. So I'm just going to move this over 1, 2, 3 decimals. So 0.0085. All right, and then times 1 million. And then I'm going to grab my calculator. So 0.0085 divided by 490 equals times 1 million is going to give me 17 parts per million. All right, so I'm doing all my work down here. So I want 17 parts per million. There it is. A sample of hydrogen gas at 2 atmospheres and 273 K occupies a volume of 5 liters. The gas sample is completely transferred to a 10-liter sealed container. What's the new pressure when the temperature remains the same? So I am going to set up my P1 V1 over T1 equals P2 V2 over T2. So the temperature is remaining the same, so I can cross it off on both sides. So I have 2 times. All right, I just moved inside because I keep pausing with this poor connection. So, all right, so I was in the middle of doing this problem, a sample of hydrogen gas, and I was doing my P1 V1. So the temperature is staying the same, and I was writing down it was 2 atmospheres and 5 liters. And so now I want to know what the pressure is if it's 10 liters. So 2 times 5 is 10. Divide this side by 10 and this side by 10. X is equal to 1 atmosphere. All right, there we go. All right, given the equation for a system at equilibrium, if only the concentration of N2 is increased, what'll happen? So I like to do the dots and the arrows. So if I add here, I'm going to move away. Wherever you add, you move away. These will increase, these will decrease. So NH3 is going to increase. All right. A hydrocarbon molecule has 7 carbon atoms in a straight chain. There's a double bond between the third and the fourth. The name would be, all right, it's a double bond, so right away I'm crossing off the ynes because that's for a triple bond. So I want a double bond. And the double bond comes after the third carbon, so that means 3, heptene. Given the balanced equation representing a reaction, what type of reaction is this? So you're taking this unsaturated molecule, breaking the double bond, and adding 2 F's in so that you have 1 product. That's called addition. Solid copper will be deposited on one of the carbon electrodes when wires are connected to. All right, if you have 1 solution, this is an electrolytic cell. An electrolytic cell needs a battery right here. So this would have to be a battery. All right, what is the volume of 0.3 molar NaOH needed to neutralize 15 milliliters of 0.8 molar? All right, so if you're not sure about this, this is definitely an MAVA equals MBVB. This is a titration or a neutralization problem. So this NaOH is my base, so I'm using 0.3 molar of my base, and I've got 15 milliliters of 0.8. Okay, and I'm going to solve for the volume of my base. So divide this side by 0.3, divide this side by 0.3. So I take 0.8, 0.8 times 15 is equal to 12, divided by 0.3 is equal to 40. I would need 40 milliliters. All right, 2 more multiple choice, people. All right, which equation represents a spontaneous transmutation? So if something is spontaneous, first of all, these aren't even nuclear, so cross them off right away. Transmutation means you're changing elements, and so if it's spontaneous, I only want one thing before the arrow, so 4 is my choice. This one right here, this is artificial. You are adding a neutron, which means you're firing a neutron at it to make it change. That's not spontaneous. All right, which one has 2 neutrons? So neutrons have a mass of 1 and they're in the nucleus and they have no charge. So this has a mass of 1 and it's just a neutron, so that can't have 2. That only has a mass of 1. This has a mass of 2, but it has 1 proton, so that can only have 1 neutron. Here we go. If it has a mass of 4 and it has 2 protons plus 2 neutrons would give you a mass of 4. All right.